Talking about engaging students using technology. I have a few different resources compiled in this digital tote. You can access it through this QR code or the bit.ly link throughout the presentation. We're going to be looking at blended learning, 3D printing, and robotics. So let's start off with blended learning. Let's take a look at this definition for a bold school. It is one that uses technology in an innovative manner to enhance instruction, as well as using old school wisdom. This coupling of old school and new school technologies is what leads to a bold school. I was introduced to this term through Weston Kieschnick's book, Bold School, which focuses on blended learning as a meaningful way to engage students in learning content. Through blended learning, we use face-to-face instruction with appropriate technology tools in order to enhance instruction. We continue to use the strategies and activities that we know that work well with our students, and we integrate different technologies to help students to master their learning goals. What's important to keep in mind is that technology is great, but teachers are better. Technology can't replace a good teacher. When I started implementing blended learning a few years ago as a science teacher, I wanted to maintain the integrity of good, solid science instruction. I wanted to focus on instructional planning, student choice, content mastery, but I needed to ensure that students were still able to participate in hands-on science labs. So I started with the science, and I focused on delivering necessary content. Direct instruction has a high effect size, according to John Hattie. I knew that I had to continue delivering direct instruction in some capacity, as well as continue providing opportunities for students to engage in hands-on labs. Then I added in supplemental activities, such as small group interventions and collaborative activities that students would complete within student learning groups. And I realized that one of the best things about the science-inclusive blended learning environment that I had created was the fact that I could be two places at once. I could provide direct instruction using screencast videos that I recorded ahead of time, and I could be in the classroom helping small groups of students with lab activities or interventions. And generally, this is what my classroom looks like. It's a lot of different things going on all at once. Some group activities, some individual activities, and a high-level engagement. This year, with COVID regulations, students still participate in hands-on activities, but those are modified so that I can sanitize after each use. And our game time is limited to digital games, but we still communicate and collaborate with one another. So what is it that I provide for students? I give students activity playlists. These playlists contain a variety of activities to engage students on different levels, meet different learning styles, extensional activities, and also a combination of digital and hands-on components. Where does all this come from? Well, I make a lot of the materials myself. I just make stuff up. Most of my review games, like this Play Money set for the Who Wants to Be a Millionaire game and the microbiology Go Fish, come from the Dollar Tree. These Jenga pieces and this box, well, the Jenga pieces came from Dollar Tree, but this box came from Chick-fil-A. I also use random craft materials and recyclables mostly. Here are a few examples of the mazes and the color by science sheets and other review games that I've used. And when you're getting started, remember there's no shame in using materials from Teacher Pay Teachers or other resources. It takes a long time to develop a critical mass of activities that can be used to give students a variety of options. I also like to have multiple mini lab options on my playlists. As a team, students can choose any of these labs to complete at any time throughout the chapter. And we still do whole class labs, but these mini labs give students the opportunity to explore certain concepts in more depth and detail. Here are a few of the different playlist templates that I've developed. These templates are available in the digital tote for this presentation. The choice board template provides students with several different tiers to meet learning styles, and each tier has several different options that are built in within it. This is one of my daily playlists. It has certain things that students need to get accomplished during the class period, as well as an early finisher option. This style playlist is great for sub-plans. I like using this weekly style playlist to give students a lot of different options. It also helps students to see the main instructional item that needs to be complete. in the mandatory activities. And it helps students with time management by breaking down the learning activities by date. So students would complete all of the mandatory activities, and then as a team, they would select different activities in the choose your own science adventure style. These playlists can even be made into end of course review activities prior to yearly exams. These playlists are great to embed into fun game formats. My PLC made this quest for the golden trilobite, and students that completed the game first won a 3D printed golden trilobite. Speaking of 3D printing, there are a lot of fun ways to incorporate 3D printing into the classroom, into your instruction, or into blended learning playlists. In my classroom, students are able to use my 2 MakerBot Sketch classroom printers. Some of my mini labs are fossil and molding, casting lab activities. For the molding lab, students use 3D printed fossil replicas and press the replica into clay to leave an impression. For the casting labs, students basically do the opposite. They're given a 3D printed mold and they make a cast from that using plaster or modeling clay. This year, some of my students are hybrid, and I see them twice a week, and my other students are fully remote. I never get to see those students except by video conference. So that means that all of my instruction must be digitally accessible. When I introduced 3D printing to my students this year, I provided students with some digital exploration through a video that I made myself that is linked on YouTube, as well as some short video clips about the applications and the future of 3D printing. Students were able to type their takeaways and their reflections, their wows and wonders directly into this editable Google slide, and they were even able to submit this in Canvas. I also gave students the option of designing an object in Tinkercad or exploring STL files in MakerBot's file repository Thingiverse. Students could also choose to make a drawing and convert it to an SVG file. I showed students how to do this and then imported their files into Tinkercad to create an STL file. Both my hybrid students and remote students participated in these activities. I printed their file on my MakerBot Sketch printers, and then students were able to take home their object. Remote students could drop by the school at their convenience to pick up their 3D print. I also use 3D printing to support and enhance the science curriculum. I printed ammonite models to show what this Mesozoic fossil may have looked like when it was alive. I also printed some different trilobites. Some that I've used in this fossil molding and casting lab, but others, like this Chimera articulatum print, are used to show how trilobites could actually move and roll up in defensive posture, much like their descendants, the roly-poly pillbugs that we see today. And think about accessibility. Being able to 3D print an item that can not only be manipulated with your hands, but can provide context for learners with special needs, such as Braille text on this periodic table, or snapping together atoms to make a molecular model, which also has Braille text on it, or arranging the valence electrons to show Lewis dot diagrams and to talk about bonding with other atoms. Robotics is another great way to engage students. I really like the Robotics product line because these products are scalable and they go from low tech to high tech. And using Google Slides is one way that I provide interactive robotic experiences to my students. In this virtual digital design challenge, students were given the task to complete, some parameters and some variables, as well as some digital robotics plates and rivets that could be manipulated to create their virtual design. And in this engineering design challenge, I tasked students with building a tower. Kids can explore robotics from the simplest version of the engineering design process to using motors, to coding, and integration of 3D printed components. The Kids Lab design line can be used by young children, and my 4-year-old daughter even helped me build this crab, and she loves playing with it. My daughter also helped me to build this gripper, and as she plays with it around the house, I can see her experimenting with and analyzing different variables, considering if an object might be too large or too heavy to be picked up, and she's delighted when she finds a toy that's just right. She goes through the engineering design process every time she uses this Kids Lab robot. In the classroom, these activities can be scaled to create items from recyclable materials like these mini scissor grippers. And these robotics items are not only scalable, but they can help students consider real world issues. For example, my students used recyclables in a biomedical engineering lab to create a prototype prosthetic. This leads into talking about the Enable program and how community of makers has been providing 3D printed and robotic prosthetics to children who constantly are outgrowing their prosthetic limbs. You can scale this activity to using hydraulics as well as some of these robotics products like this manipulator arm. Thank you so much for attending. If you have any questions, please feel free to reach out.